If they differ in either of the two, then it is called as unequal. You know, parallelogram is given in terms of all four sides which are parallel to each other. How do you represent a vector now? It is represented by a line segment. Equal vectors are the vectors whose direction is also same as well as magnitude is also same. Hello everyone, I am Vrinda, Faculty of Physics from Vidhyaashram School of Excellence, Mysuru, welcoming you all to session 1 of chapter Motion in a Plane. So in this chapter, we are going to deal with how exactly the movement takes place in case of plane. Whenever a concept called as plane comes, we have to check on with the plane in the sense axis. There are two axes. Which are those? As you know, one is x-axis, one is y-axis, and another one is z-axis. So here mainly we'll deal with XY axis and XYZ axis. 2D and 3D concepts is what we study over here in this motion in a plane concepts. Okay, so we need to know how exactly the movement of the particle takes in one axis, that is either in x-axis or in y-axis or in xy axis. Okay, so we have here one dimension, which means to say we have x-axis over here. Okay, so in 2 dimension we have x-axis, we have y-axis. In 3 dimensions we have x-axis, we have y-axis, and we have z-axis. So we have 3 axes. So that is called as 1 dimension, 2 dimension, 3 dimensions. There are 3 dimensions we have to know, 1, 2 as well as 3D, which can also be called as 1D, 2D and 3D. So this is how exactly it goes. Okay, so we are studying motion in a straight line was studied under 1 dimension concepts and all, and motion in a plane we study about 2D, 3D concepts, how exactly the movement of an object or a particle takes place in case of 2 dimensions and 3 dimensions concept. Okay, so now we have scalars and vectors. So as you all know, whenever we come across this motion, okay, there we study scalar and vectors. Okay, what exactly is a scalar? What exactly is a vector? Scalar is the component, okay, which has only magnitude. What is meant by magnitude? Which means to say it is values. Okay, so vectors are the one which has magnitude and direction also. So it includes magnitude and direction, but where in case of scalar, it includes only magnitude and no directions. So as you all can see, this is actually the examples, the images whichever is given here is nothing but your scalars as well as vectors. Okay, so I just want you to know the physical quantities. There are 2 types which is used to represent the motion of any object or the stability or isolated object. Okay, which means to say scalars and vectors. Scalars are the one which has values, which possess values, but it doesn't possess any sort of direction. Vectors are the one which direction as well as magnitude. So as we know that motion in a plane chapter, motion concept is there. Motion means movement. When a person moves from one place to another, he carries the value, what distance he has travelled, at what interval of time he has travelled and all we check. Okay, along with that, in which direction he has moved or in which direction a particular object has moved is what we check. So here afterwards we have to deal with vectors. So we drop scalar here itself and we carry out vectors here. Okay, so now we are dealing with vector concepts. So representation of vector. How do you represent a vector now? It is represented by a line segment. Okay, the line segment, whatever you can see, it is just one single line segment. Arrow indicates the direction of vector, towards which direction it's moving, so direction of a vector. So this is one of the most important component in this chapter, motion in a plane, which will carry marks. Arrow mark is must and should. It shows the direction of the movement. Okay, next is analytically, vectors are represented in terms of arrow on it. This one and this one both are one and the same. How do you represent the magnitude of a vector? Magnitude of a vector is nothing but the ratio of vector quantity. This is how exactly you give the magnitude of a vector. So this is the representation of a vector. So let us check how many types of vector is there. You know what is a vector? How is it represented? So let's see its types. No, there are these many types of vectors. It's looking colorful, but when we study it is very easy too. Okay. So now we have localized and fixed vectors, non-localized and free vectors. That means its point of intersection is free. Okay. Fixed vectors will have a fixed point over here, one head and tail method. This is a tail, arrow is a head, so its tail will be fixed. That is called as localized or fixed. Non-localized or free vectors, which is free to move. Vectors will be very much free. It will not have fixed tails. Collinear vectors, that means it is in the same direction. Collinear vectors are the vectors which are in the same direction but different magnitudes or the values. Okay. Equal vectors are the vectors whose direction is also same as well as magnitude is also same. Next is negative vector. Negative vector, one, its direction is opposite to that of each other. We have unit vector. Unit vector, here we can give a cap, can be a unit vector which has a vector quantity divided by magnitude of the vector quantity. This possesses the unit vector. This formula is very much important for solving few numericals. And orthogonal vectors are the vectors which are having I cap, j cap, k cap concept. So if we have x-axis, y-axis and z-axis, with respect to x-axis, the unit vector which is associated is unit I cap. Okay, I cap is a orthogonal vector. With y we have j cap, with z we have k cap. This is how exactly the following terms goes with respect to orthogonal vectors. Coplanar vector, which is having the same plane, vectors shown under same plane, such kind of vectors are called as coplanar vector. And polar vectors are the vectors whose direction is along the direction of motion. Such kind of vectors are called as polar vectors. Axial vectors are the one which lies in the axis itself. And null vectors are the vectors which is called as zero. Zero vectors and null vectors are both are one and the same. Okay. Next we have position and displacement vectors. How do you represent the position and displacement of an object? Okay. That gives you the vector combination concept. So it is totally called as position vector or displacement vector. To describe a position of an object which is moving a plane, we need to choose a convenient point. So its origin has to be O. So convenient point, if we just check, this is x-axis, this is y-axis, and there is some point over here. Let me call this point as P. So now, to describe the position of an object, and the object what I have written here is P, is moving in a plane. So this is a plane, XY plane. Yes, 2D is what we are considering here. We need to choose a convenient point, say O as a origin, not somewhere else. It always starts from the origin where the intersection of the axis takes place. From here to this part, and with an arrow gives you the direction as well as magnitude of a certain point. Okay, next. Let P and P dash be the position of the object at time T and T dash. So suppose if this is a P at time T and there is another object somewhere here at P dash at time T dash. So suppose if this is the position vector T at time T, the object is somewhere else to which the position vector we have given. So let us mention that position vector as R here, and here it as R dash. These two are the position vectors of P and P dash at certain time interval T and T dash. If that's the case, we have OP is R, OP dash is R dash. Length of the R is the magnitude of the vector. Whatever length of this arrow mark or R is given, that is nothing but your magnitude. Magnitude means it's a value. Okay, the object, if it moves from P to P dash, then the vector is known as displacement vector. Now I'll tell you what is displacement vector. Suppose if this from this point to this point, if the object is moved in this manner, then that is known as displacement. It is getting displaced. That will be change in position, delta R. So your R and R dash are the position vectors, whereas delta R is called as a displacement vectors. So that's all about your position and displacement vector. Next, we are going to equality of vector. How do you give this? Equality of a vector. There are two vectors, vector A and vector B. They are equal if and only if they are having same magnitude and same direction. If they differ in either of the two, then it is called as unequal. Equality of the vectors is nothing but the one which has same magnitude and same direction. Next, we are going on to multiplication of vectors by real numbers. How do you multiply a vector by a real number? Real number, if suppose 2 is a real number, so you have a vector A, that is vector A we mention usually. So with positive number, we have lambda. Okay, real number here I have considered 2. There they have considered lambda. It can be either of the two. Any real number gives a vector whose magnitude is changed by the factor lambda. So if you multiply a real number with a vector quantity, you have lambda into A. Okay. But in the same direction as that of A, we have the value. It will be changed by a factor lambda, but it will have the same direction as that of your A. That is called as your multiplication of vectors by a real numbers. Next is addition and subtraction. These are all arithmetic operations which is held with respect to vectors. So multiplication of the vectors is over. Now let us check how to add as well as how to subtract. It is not that direct that you have to add and subtract. We have certain rules and regulations for it. For the multiplications, we have already carried out. We know how exactly it goes. Multiplying it with the same real number. Multiplying a vector with a real number, we get vector times that of the real number. Okay. We get real number times of the vector. Next is addition. Addition can be done by graphical method or mathematically. Okay. So it's with respect to triangle law of vector addition, parallelogram law of vector addition, polygon law of vector addition, wherein this we don't study in your syllabus now, right now. So now it is only triangle law of vector addition, polygon law of vector addition. How exactly it goes? In triangle law of vector addition, how is the triangle represented? 3 sides, correct? And vector means you should know arrow notation has to be there. Okay, so if 2 sides of the triangle is represented by certain magnitude and direction, okay, tail to head, okay, then one more line you want for your triangle to be filled. 1 side is over, 2 side is over, 3 side we not. 3 side we need. So if 2 sides of the triangle represents direction and certain direction and magnitude, then the third, this will be in the same order. Then the third side of the triangle will represent an arrow mark which gives you the resultant vector of the different order. Okay, which means to say tail to head, tail to head. For this, we have head to tail again. For head, we are attaching a head. So arrow mark is must. This arrow, this arrow, this arrow. 3 arrows are must and should. Consider if suppose this is vector A and if this is vector B, then we can, how can we give this addition as? Adding vector A plus vector B, we have to get a resultant vector. So this is the triangle law of vector addition. Similarly, we have parallelogram law of vector addition. So how do we go on with it? You know, parallelogram is given in terms of all 4 sides which are parallel to each other. So suppose if there is 2 sides which is given under say certain directions and magnitude, call it as vector A, vector B, which is having a fixed tail. Yes. Okay. So if we are having this concept that the 2 sides of the parallelogram are adjacent to each other, then the diagonal which is drawn from that point of intersection gives you the resultant vector. So this is the parallelogram law of vector addition. Okay. So that is about your parallelogram law of vector addition. And next we are moving on to subtraction of vectors. In case of subtraction of vector, the difference between 2 vectors A and B is the sum of 2 vectors, which means to say, suppose your A vector is this. Suppose you have a B vector opposite to this. Okay. So it is subtraction of vector A minus of vector B is equal to resultant vector is nothing but vector A minus into minus is plus vector B is equal to resultant vector. That is what the sentence tells you about. So this is how exactly subtraction of vector goes, okay? Two vectors should be opposite to each other. Next is zero vector. Zero vector means if the displacement of any object starting from P and ending at P. If it starts from P and again it goes somewhere and all and comes and ends at P, then the displacement vector whatever is there is here itself. So it is same as that of the displacement, so it is 0. So it gives you a zero vector, okay? Resolution of a vector. So how do you resolve a vector? Resolving a vector. So one vector will be there, we are dividing it into two, okay? So let A and B be any two vectors in a plane with the different directions and let A be its resultant vector, okay? A and B are said to be any two vectors in a plane, okay? It is with different directions. So we are not considering this now. So let us just stick on to this, the resultant vector. We have axis as x-axis and y-axis. And suppose if there is a vector called as vector A be the resultant vector, sum of two vectors A and B, we can resolve it generally into rectangular coordinate system. That is using magnitudes known as this unit vector. Suppose if there is a light which is falling from top of this. Where does its shadow falls? It falls on the x-axis. So it is on the x-axis. So I just draw this thicker line. So we have vector A shadow over here. So A in which axis? X-axis. It is associated with one orthogonal vector, and always for x we have I cap as a orthogonal vector. Similarly, if I keep a light over here and on it, what happens? It gets the shadow which is fallen over the y-axis. So I'll just thicken the line of y-axis. So we have this part is called as A in y-axis and it is associated with the orthogonal vector. It is j cap. So we have I cap and j cap. So this is how you exactly resolve. You are dividing a vector into two components. Okay. So that is called as resolution of a vector. So as you can see here, resolving vector A in terms of component of I and j, the same what we had done. Here it is a vector A. You are resolving it. So we have A x I cap and here it is A y j cap. That is how the resolution of vector turns out to be. Next we have the velocity. According to this velocity, we have average velocity, instantaneous velocity, everything. Okay. So velocity is nothing but, as we have studied, displacement by time taken. Okay, so average velocity is how many number of velocity is being taken from each and every point, that point divided by total time taken, average velocity. In final minus initial, from the final velocity you neglect initial velocity so that we get total time taken. Okay, can take delta r by delta t. Delta r by delta t in the sense displacement from, suppose if you are taking x-axis, y-axis, there is two points and the distance separately. So it is P and P dash. This displacement is delta R, change in the position. So change in position with respect to resolution of a vector, if you go, delta R can be given in terms of x-axis as well as y-axis, both the axes. So delta x into I cap plus delta y into j cap divided by, we have delta t. Can be written as change in displacement by time taken is velocity, delta v x I cap plus delta v subscript y j cap. Okay. So this is how exactly your average velocity can be given. Instantaneous velocity means at certain interval of time which is given with respect to limit. So instantaneous velocity can be defined as limit delta t which tends to 0 with the rate of change of displacement with respect to time. At certain instant of time is being calculated over here. So there is a limit which occurs. Okay. So this is all about your velocity. Next is acceleration. We have three types: acceleration, average acceleration, instantaneous acceleration. Acceleration is nothing but your speed varies for each and every interval of time. That is called as acceleration. So acceleration is change in velocity with respect to time taken, wherein velocity was displacement by time taken. So if we give with respect to this average acceleration, you have delta Vx I cap plus delta Vy j cap. One is with respect to y-axis, one is with respect to x-axis. That is due to resolution of a vectors, and delta t. So on solving this, velocity with respect to time is acceleration. So delta acceleration ax I cap plus delta acceleration subscript to y j cap. One is with respect to x-axis, one is respect to y-axis. We need to have two axes because we are studying motion in a plane. Okay. So this holds good for average acceleration. Again, with respect to instantaneous acceleration, it's simple, that is limit delta t, the time, change in time tends to 0, wherein change in velocity with respect to time is given. So this holds good for your instantaneous acceleration, which means to say acceleration at particular instant of time. So in today's class, we have dealt with the motion in a plane, first chapter, just the introductory concept, what we have to know to study the further concepts. Let us all meet in next upcoming session. Until then, have a good day. Thank you.